The CLO for this lesson is that students will be able to create, in writing, equations using linears, slope, and y-intercept, graphs, tables, and equations, as well as the following language: if-then statements, linear, slope, y-intercept. In your own words, please explain what you think you're going to learn how to do in this lesson. So if we begin with the vocabulary, so we're going to be creating equations. And remember, in math, equations are a list of numbers and operations that show how the input gets affected to create the output. So, for example, if the equation is that the answer, the output equals 3 times the input plus 1. This is an equation because it's a list of numbers and operations like adding, and it shows that the input, the x, gets affected by being multiplied by 3, then getting added to 1, and that's how you create the output, the y. So that's what an equation is. And in equations, in linear equations, because that's the type we're working on, we have something called slope. And if you remember from the last lesson, slope is how much your amount is changing by, divided by how much time is going by. So that ends up turning into your unit rates when you divide it. Another word for this is called your growth, because if it's positive, then you're getting stuff. However, if your slope is negative, then you're losing things. And it's also called your rate of change, because it is your rate, how fast you are changing. So the bottom tells you how fast, and the top tells you what you're changing by. Something else we're going to use in linear equations is something called the y-intercept. So mathematically, the word intercept means to cross. And when we're saying the y-intercept, we're talking about the y-axis. So remember, the y-axis in a graph is the up and down line. And any point on the y-axis is considered a y-intercept. So for example, the point 0, 1, right here in purple, is a y-intercept. So is the point 0, 1.5, this one right here. Anything that's on this up and down line is considered a y-intercept because it's on this y-axis. But what's special about both these points is to be on the y-axis, the x has to be 0. Because then it doesn't matter if you go up and down, but it does matter you cannot go left or right if it's going to be a y-intercept. It needs to stay where x is 0. But the y can change because it can go up and down. So for y-intercepts, x is always 0 because you're not going left or right if you're staying on the y-axis. And if x is 0, remember, in situations, x represents the time, which means no time has passed. Because if x is always going to be 0 for y-intercepts, that means for y-intercepts, it's always when no time has passed. So it's also sometimes known as our starting amount. Because if no time has passed at all, then that's how much we start with. So like if my y-intercept, for example, is this 0, 1, that means when no time has passed, I have won something. So if it's about money, then I have $1. Or if it's about candy, then I have 1 piece of candy. Before doing anything, before going to work, before going trick-or-treating, whatever it's about, before doing anything, I have 1 of them. So it's considered my starting amount. So this whole unit is about linear equations, and it's a specific family type linear equations are that when we graph them, they make straight lines. There are other types of equations, like this one. See how it kind of makes that U? Or I can start making them look real weird, like this, and it kind of makes this little S shape. And there's all types of equations in this world, um, and they all make different shapes. And in math, you're going to learn about a bunch of them, and you're going to be expected to create equations for all of them. But the ones we're focusing on in this lesson are the linear equations. So this whole unit's about linear equations specifically. And so if we have to make linear equations create graphs, straight lines. So this word problem's an example of a linear situation. And to figure it out, let's just talk about what's going on. It says London has 10 cars. Each year, she plans to buy 2 more. If she has 18 cars, how many years has it been? So one way to solve this is you can like count. So I have 10 and I'm gonna buy 2, 2, 2, and keep counting till I have 18 and figure out how many years has passed. But to do it more mathematically, we could create the equation. So in math, remember x represents time. And in this situation, when does it talk about any sort of time? It says each year. So x in this situation is talking about how many years it's been. So if I try to create this without the totals yet, it says London has 10 cars. Each year she plans to buy 2 more. So this part's about the total. So let's not talk about that. So we're going to focus on this. So I have 10, she has 10 cars. Then she's going to add 2 more every year. So if 1 year has gone by, she adds it once. If another year has gone by, she adds it again. If a third year has gone by, she adds it again. Well, this 2 plus 2 plus 2 is the same thing as 2 times 3 because it's been 3 years. And so for years, instead of writing 3, because I don't know, it could change. It could be 3 years, it could be 4 years, it could be 5 years. So since the years can change, we call it X. So depending on how many years go by, like if it's 4 years, then 2 times 4 would be 8 more cars plus the 10 she already has. But we're going to put X there because the amount of years that goes by, how many years it's been, that can change. So this is the equation so far without the total. But then in math, remember y always represents amount. And so in this situation, we're talking about what? The amount of what? It's the amount of cars. So when we add the fact that if she has 18 cars, that means they want us to take it and make it equal 18. Then if I solve for x, I would find out the answer to the question. But I don't need to find the answer to the question. We're working on writing these equations. So in this situation, what was our growth, our slope? Well, it's the 2 because each year I get 2 more. So that's what I'm growing by, or 2 per year. So 2 cars divided by 1 year, meaning my slope is 2. And then how much did I start with? What's my starting amount? Well, London just has 10 cars right now. So she's starting with 10. So that's my y-intercept. So in general, the formula for any linear equation is always look like this. Y, meaning the amount I have, equals m is my slope, then x is my time, plus b is my starting amount. So m is slope. And we always multiply our slope to the x. So slope is always with the x because our growth times how much time has gone by. So if I'm growing by 2 each year, I need to times 2 by however many years have gone by. Then I add my b, my starting amount, my y-intercept. So just to reiterate, the m is where we put the slope. The b is where we put the y-intercept. But we do not change x and y when we're making the equations, because equations have x and y in it. Now, like I can give you x's and y's to plug in. However, x and y can always change in any situation. However, the equation for a situation, the m and b won't change for that situation. Here are some examples. This one says create a linear equation. So because of the words linear equation, I know it's going to look like y equals mx plus b, where the slope is 1/3 and the y-intercept is -5. So slope goes into which one, the m or the b? Slope always goes into the m, and the b is what? B's -5. But if you're saying minus, like -5, you delete the plus, and you just say 1/3 x minus 5, because that's what it means if the b is negative. So this is the equation for this situation. The next one says create a linear equation where the y-intercept is 2 and the slope's -3. So what goes in the y spot? The y. You do not change it. Not when you're making the equation. What goes in the m spot? The slope right now is -3. And then what goes in the b spot? It says the y-intercept's 2, and because it's a positive 2, we just say plus 2. Now this is the equation for this one. So let's make it like a real life situation. So this is a situation that says Jenny has $20, and every day she can earn $5 for doing the dishes. We need to write an equation to represent this. Well, what is this 20 that she has? Is it the slope or is it the y-intercept? Remember, slope means growth, and she's not getting 20 each time she does something. She just has that 20. That 20 is her y-intercept, because that's her starting amount. She just starts with that. She has $20. Then her slope is that every one day, so one day is on the bottom of the fraction, and on top of the fraction, she gets $5 for doing that. And 5 divided by 1 is just 5, so her slope is 5. So in the equation, in the m, I put a 5, and in the b, I put a 20. And that's the equation for this situation. So this one says a pool has 5 gallons of water in it. It gets 8 more gallons of water every 3 minutes. Write the equation to represent this. Well, if we start with slope, on top of the slope fraction is how much more I'm getting. How much more am I getting? I'm getting 8 more gallons. So 8's on top. And on bottom is how much time it takes to get that 8 gallons. So how much time does it take? Well, it gets that 8 gallons every 3 minutes. 3's on the bottom, so that's my m. If I do 8 divided by 3 in the calculator, I get a decimal. So I would prefer to leave it as a fraction because I like them better than decimals. Then what's my y-intercept? How much water does the pool start with? Well, it says the pool just has 5 gallons, so it's starting with 5. So now when I make my equation, y equals the m, the slope is 8/3, and then x plus my 5, which is my starting amount. So that's the equation for this situation. If I have to do it on a graph, again, I'm just going to pull out the slope and then the y-intercept. So for the slope, I pick 2 points. Look, they gave us 2 points, and I connect them with a slope triangle. So I'm going right 1 and then up 1, 2. So for my slope, which one of those numbers goes on top? It's the change in y, which is up 2, then divided by the 1, which is the x. And 2 divided by 1 is just 2. So in my equation, the m is 2. And what's my b, my y-intercept? Well, this graph is crossing my y-axis right here at 3. That's where the line's crossing the y-axis. So my b is 3. So then instead of b, I write 3, and there's my equation for this graph. So before I do the math on this one, I'm going to explain what this table means. So this says figure number, and this says number of tiles. So basically, this is what it means. You have a picture, and let's say figure 1 in your picture looks something like here's 1 tile. So tile is like a little square. And let's say here's another tile. And another one. And another one. So I'm at 4 so far, but it says 1 has 7 tiles. So here's 5, 6, 7. Then let's say figure 2 has one with 12 in it. So there'll be a picture with 12 figures. Well, from 7 to 12, we're adding 5. And it's always going to follow a pattern. So this is the same picture right now, but I need to add 5 more to it. So let's say I'm going to add them in this purplish color. So let's say the 5 I add is adding 1 to the side, 1 to the bottom, 1 to the top, and then 2 more to this side. So that's a total of 5 more. 1, 2, 3, 4, 5. So that's figure 2. Then if I want to do figure 3, well, figure 3 also gets 5 more, and it's going to be in the same, it's going to follow the same pattern. So figure 3 so far, it isn't done. This is figure 2. I just copied these 12 tiles in the exact same way over. So now I'm going to add 5 more, and I need to add 5 more in the exact same spots. So it was 1 to the top, 1 to the left side, 1 to the bottom, and then 2 to this right side. So 1, 2. So now there's a total of 17 figures because I just added 5 more in the exact same spot. So here's this thing with figures. If this is the first one, in order to figure out figure number 0, it's this pretend idea, where if I go before the first figure and got rid of the same ones I was adding on each time, so I get rid of this side one, this bottom one, this top one, and the 2 on the right. If I make those go away, then I am only left with the middle 2 because I took the 5 around it away that I've been adding on. So that's why figure 0 would have 2. So that's what this is talking about. It's talking about figures, like images, and how many tiles are in that picture. And they're usually always going to follow a pattern where you're adding the same amount to the same spots each time. When you do it on a table, for slope, you figure out how much it takes to go from here to here. So from this
Figure number 0 to figure number 1, we're going up by 1. And then the number of tiles, if it starts at 2 and then goes to 7, that's adding 5. So between the two numbers, which one goes on top? Remember, it's the amount of tiles, not which one it is. Like which one it is just which number you're on. Are you on the first one, the second one, the third one, the fourth one? But the number of tiles tells you how many that one has. So it's going up by 5 tiles for each one new figure. And 5 divided by 1 is just 5. So that goes into my m. And then what's my y-intercept in the table? Remember, for y-intercept, it's when the x is 0. So this is where x is 0 and the y is 2. So figure number 0 starts with 2 tiles. So then my plus b is plus 2. And that's the equation for this table. So using if-then statements in the vocabulary linear slope and y-intercept, explain what you learned how to do during this lesson.